Hello, welcome to today's Snack and Learn webinar. We're pleased to have you all here today with us. Just mentioning the housekeeping items quickly. This is a longer webinar. It's around 45 minutes in total, with a 30 minutes presentation followed by Q&A. There will be time for questions, so please log your questions in the question box on the control panel. And also you can find in the handout box as the the presentation slide as a PDF. I will hand it over to Sagar and Beverly to start the presentation. If you can both open your cameras. Thank you.
Greetings, everyone. WSP is pleased to welcome you to our global webinar series. And thanks for joining today's webinar, where we plan to discuss on the topic of developing Power to X projects. With the great interest shown by many of you to participate on this webinar, we can presume that many of you also believe in the significance of hydrogen as a decarbonization solution, but not necessarily satisfied with the pace of developments of hydrogen projects. It is difficult not to have a day pass without hearing some news on hydrogen from some place in the world. The news could be related to policy introduction, could be technology breakthroughs, project announcements, funding availability, or some utilization pilots. All these signposts indicate the rapid acceptance of hydrogen and its significance. The objective of today's webinar is to share our perspectives on what's causing the delay to progress to final investment decision, even though the initial announcements of hydrogen projects have been growing at an exponential rate. Before we go further, why don't we introduce ourselves? Beverly, do you want to go first?
Sure. Good morning. Before I get started, I wanted to say that I'm so honored that we have such a diverse global audience tuning in today. Thank you all for choosing to be here with us. My name is Beverly Pilling, and I'm the National Market Lead for Hydrogen at WSP Canada. I'm based out of Calgary, Alberta, where I've been working in the energy industry here for 20 years. Our WSP Canada team has been executing hydrogen projects for over a decade. With a more focused approach these last 5 years, we have completed scoping projects through detailed engineering on various sizes, from 1 megawatt to gigawatt scale in size. Sagar and I look forward to sharing some of our thoughts and lessons learned with you today. Sagar, over to you.
Thanks, Beverly. And I am Sagar Kanchala. I lead the Energy Transition Advisory Group for WSP Canada and based out of Toronto. The advisory group complements the engineering talent, such as Beverly, in helping energy stakeholders navigate from high carbon fuels technologies to low carbon fuels and technology, specifically helping clients in developing their business strategies, interpreting policies, and more important, de-risking their investments to participate in the hydrogen economy. Along with Bev, we worked on many studies and investment reviews for hydrogen in Canada, US, Nordic region, and New Zealand. Next. The agenda is pretty straightforward. I think in the next 25 minutes, Beverly and I will present our perspectives, share some project experiences, and then respond to your questions that you might have. To get started, let's understand what Power to X project is. Whether it is a carrier or an end product, we're seeing many projects of using hydrogen as a derivative, converting hydrogen into a derivative. In this context, Power to X is essentially converting electricity, predominantly renewable power, into other valuable forms of energy and chemicals. These could involve multiple process steps. While many aspects of our discussions could be applicable for hydrogen projects involving other feedstock, we will focus primarily on Power to X projects today. Let's look at some recent statistics. Hydrogen Council, along with McKinsey, publishes hydrogen insights. Probably many of you must have seen the last report, which has come out in December 2023, public 2023. And what you could infer is that as of October 2023, there's been 1.1 gigawatts of hydrogen capacity being developed, deployed, and 12 gigawatts of projects have passed the final investment decision. This is good progress from previous year. When you look at chart A, here on the announced projects, it has an investment value of 570 billion. And growth is also seen in the projects progressing from the announcement to the planning stages. But when you look at carefully at the last column of the committed in chart A, the committed investments, these are investments that have passed the FID, is a very small portion. Chart B is just looking from a plant capacity perspective. And this has also shown good growth from the previous years. It's now projected to have 45 metric tons per annum capacity from all the projects announced here. But what you see from chart A and chart B is that the good pace of projects announced is not good enough. And in chart C, it shows the ambition that the industry has to have 1 billion of projects announcements by 2030. So the gap is still 430 billion. So not only the pace, but there is inadequacy of projects announced today. Another critical observation where the gap is, there's been lots of focus of projects on the supply side, but when you look at the midstream assets like the delivery side or the end use applications, that's where the significant gaps. And all of us know that that's where it takes significant time to develop the midstream assets. So let me pass on to Beverly to hear what's causing this delayed process.
Great, thank you, Sagar. As Sagar mentioned, there's $570 billion of investments announced at the end of last year. So why are only a small portion of those making it past the final investment decision? We want to look at right now, these projects are very complex, multiple stakeholders, elaborate processes, and most importantly, a high degree of uncertainty. With respect to stakeholder management, sorry, all projects are impacted by external influences, and Power to X are no exception. With many projects working to understand viability in a specific region, stakeholder management is one of the largest project risks that these projects face. With respect to development timelines, these will differ depending on the product type and amount, but most projects announced globally have optimistic production dates. They're often faster than the development timelines allow, which can be seen as a key challenge. Also, when you consider industry governance and look at just the last 5 years alone, there's been tremendous change in how and what regulatory body will govern hydrogen projects. This is still evolving globally as new standards are issued, what feels like daily. You might be thinking that this is no different than any other major project that's been developed globally. You know, when you think about transportation or bridges or roads, large infrastructure, they all have complex delivery, stakeholder management, development timelines, and governance changes. But what's really different for Power to X is that there isn't much history of project completion. So regardless of that lack of history, many projects are considering gigawatt scale, multi-billion-dollar investments without much to go on from the past. Within these key challenges, we'd really like to dive into today a little bit more on areas of uncertainty, some barriers, and then areas of opportunity as they relate to Power to X projects. So first of all, just talking about some areas of uncertainty. You know, when making billion-dollar decisions and investments, the presence of uncertainty will increase project risk. So where's the uncertainty coming from in P2X projects? The first thing we want to talk about are project pillars. So that's a term that we use here at WSP. So what are P2X project pillars? These are the components of a project necessary for a project to be viable. So you can't just have one of them, you have to have multiple of them to have a successful project. Access to the pillars has been unpredictable and inconsistent depending on where you look globally to develop a project. So for example, when you look at Atlantic Canada, for those of you on the call from Canada familiar with the landscape here, Some of the jurisdictions in Canada required an entirely new government process to acquire land for development for power. And those final approvals for land were limited. So even if you applied and filled out all the necessary paperwork and did all the necessary work, it didn't mean you were selected. So access to those project pillars can lead to a lot of uncertainty. The next area we wanted to talk about real quick is scalable technology. When considering, our team has had many conversations with how to scale up megawatt technology to gigawatt scale production. In doing so, we've asked questions about the effects of efficiency, degradation, heat generation, waste streams, footprints, and so on. While most of the vendors do what they can with the data from pilot projects or demonstration projects, the real answers will come when one of these gigawatt scale facilities is up and running. The good news, though, is that equipment manufacturers have shown up in a big way. Many have chosen to scale up their manufacturing capabilities as they wait for the first gigawatt order. So they will be ready when the orders come. Another area of uncertainty is infrastructure. So once you make this hydrogen, how do you move it from user to off-taker? Engineers around the world are working together to utilize existing infrastructure where possible and to develop new ways to build new infrastructure. So when scoping a project, infrastructure is very, very critical piece of uncertainty. Last but not least are the regulatory bodies. So while governments and industry are doing their best to update regulations, specifications, guidelines, it's very difficult to keep up with how quickly the market is evolving globally. An example of that real quick is the upcoming withdrawal of ASME B3112, which is what most of us are using in Canada right now for hydrogen piping design. Once that ASME B3112 is withdrawn, those components will be put back into ASME B318 and B313. That process is starting now in 2026. There is no update right now as to when that process is going to be finished, but it's just an example of how quickly things are evolving in the hydrogen and powered ag space, and it's a lot of work to stay on top of it. Sagar will now take you through some development barriers.
Thanks, Beverly. Assuming we overcome some of the areas of uncertainty that Beverly was just talking about, the sector still faces a lot of development barriers. Let's look at some of them. Market readiness. We've seen in the initial slides the inadequate pace of projects development and the investment gap that exists still. While as a developer of these projects, you could be ready with your production facilities, barriers could exist from a supply side and the demand side perspective. For example, if you're looking at renewable power as a source, is there adequate power for your production facilities? We know that electrification is also one talked about for decarbonization. So is there adequate power coming into your facility? And on the demand side as well, it's which sectors will start switching over to hydrogen in their applications. There is talk that there could be some parity when it comes to mobility of utilizing hydrogen. But what are the other sectors that will switch to hydrogen if the status quo solutions are more desirable? Then look at the equipment manufacturers. With the number of gigawatt scale projects being announced, this is absolutely music to the ears of electrolyzer manufacturers. Many OEMs have scaled up their production facilities to meet this global demand. But as an OEM, there must be some balance between supply and demand. If lots of these projects are not progressing to the FID, the manufacturers are stuck with equipment in their warehouses. So contracting strategies will play a key role here, and that barrier removal is very important to progress on the projects. When you speak to many financial institutions, three key things that they insist on for de-risking projects to become bankable. One is technology risk, EPC risk, and the other one is offtake risk. So let's look at the last one, the offtake risk. Currently, it seems to be a high portion of the incentive programs are targeting the supply side. If the offtake markets are not ready or find status quo solutions more economical, the hydrogen projects will find it difficult to have customers for their projects. So this will have an impact on projects getting financed. And another barrier I would like to talk about is the project financial performance. There is a belief, and still there is, that hydrogen technology will follow the learning curve of previous technologies and lowering the costs of production. But the electrolysis life cycle cost is only about 30 to 35% of the total project costs. More costs are towards the power consumption. So that means it leaves less opportunity for rapid cost reduction. Further, the sector is not witnessing lower costs in the last couple of years, but higher costs due to supply chain issues, and we are in a high interest rate environment. Now that we covered some of the barriers and uncertainty, let's look at the opportunities to accelerate these developments.
Thanks so much, Sagar. This is the exciting part we wanted to get to today, all the opportunities. There's so many when developing P2X projects. We picked 4 themes we wanted to talk about today. I'm sure there's many others that people could identify, but the ones we wanted to talk about specifically were environmental processes, government incentives, development partners, and knowledge development. So I'm going to jump in here one at a time here. So environmental process, especially in Canada, is very predictable and prescriptive. So what that means is it removes uncertainty from the equation, and that's something that's very, very important when developing new projects like this. While the timelines may represent the critical path for projects to meet first production goals, the process is the same for everybody. Everyone does the same 5 steps as outlined here on the slide. You can see this is from the Government of Canada website. It identifies the stakeholders, it identifies the steps, it's predictive, so the uncertainty goes out the window. So having a prescriptive process is very favorable for development of these projects. The next opportunity we wanted to talk about that's very encouraging is that governments across the globe are very supportive of hydrogen and P2X projects. We just touched on a couple of the announcements globally here on this slide, but programs have broadened from simple funding incentives to tax credits, contracts for difference, demand-side decarbonization, and so on. What's excellent and welcomed by industry is that the government has consulted with industry before making those final decisions. Just recently, the Canadian government asked for feedback on the Canadian investment tax credit. We were able to provide that feedback for some of our clients, and it's great that the government took that feedback, are listening, and will be incorporated before decisions are made. We expect similar feedback to be as part of the revision of the IRA and the 45V in the US. So it's really great that government's listening and taking our feedback and putting that into legislation before it's final. So that's a very good opportunity. The third one we want to touch on is collaboration and partnerships. This will thrive in the P2X market. There are so many benefits to having development partners, and we've seen that this is a global industry and not regional. It's global across the board. So having the right partner and can bring a trusted reputation with local governments and other stakeholders, which can be key. Working with global companies that understand local knowledge and have global reach can really drive sustainable growth for your developments. Development partners also save time and money by maximizing resources and sharing those specialists between different organizations. You can work directly with financial institutions and banks to raise capital for project expenditures. And I know a lot of the P2X projects, that's a big piece of it, is working with financial institutions to get the funding needed for these projects. And also aligning with co-developers or off-takers to make a business case stronger. If you can develop the production and have an off-take agreement signed for that production, it just makes the business case that much better. And last but not least, the knowledge growth. The last 5 years around hydrogen development and Power-to-X has been astounding. When all of us read LinkedIn every day, the newspaper, energy journals, there's so many articles on hydrogen, Power-to-X, what that looks like, successful pilot projects, projects that have been commissioned around the world. As new technologies are developed, this makes the process much better. It's a very exciting time to be an engineer in this space. And Sagar and I would actually like to take you through a couple of case studies before we get into the Q&A about how we apply these areas of uncertainty, development barriers, and areas of opportunities to some business cases here in Canada. So I'm going to jump in here with an example specific to Canada. I know there are some global attendees here, so I apologize in advance that it's a Canada-specific example. But in Canada, the energy sector is very prominent in Alberta and British Columbia. Energy companies that have been operating here for decades are looking for low carbon solutions to support their decarbonization goals. There have been several recent announcements of hydrogen to ammonia projects in Western Canada. So the X in this P2X example is ammonia. Should all these projects go ahead, this would mean ammonia would travel from Alberta, Edmonton, Fort Saskatchewan, through to Prince George, over to Prince Rupert for export for the west coast of Canada. So again, to tie this back to our areas of uncertainty, I'm not going to touch on every bullet point here, but I'm just trying to tie it back to sort of the knowledge we brought in our previous slides. So for example, in British Columbia, renewable power is an area of uncertainty in both BC and Alberta. So BC right now has a call for power, which will begin this month as they look to add renewable resources to the power grid. So they need to expand their capacity in British Columbia. In Alberta, just recently, there have been new rules regarding renewable power projects, but this process remains a little bit undefined, leading to some uncertainty in areas. So, that's one area where we see some uncertainty, but there are ways through it to mitigate it, as always. Many of the P2X projects in Western Canada started prior to 2020, and announcements of which governing body would be responsible for hydrogen actually only came in the last 2 years. So in Alberta, the AER announced in October of 2022 that they would be regulating hydrogen. And in BC, the BC Energy Regulator just announced just this past September that they would be regulating hydrogen. So changes in governance have happened and the projects are adjusting and pivoting to deal with those changes. Moving the product from Alberta to BC will be a key challenge. And regardless if it's pipelines or the rail network, stakeholder engagement and planning to move that hydrogen and ammonia will be significant and a big piece of uncertainty for those projects. It's also critical to consider emissions abatement strategies across every step of the value chain. So, carbon intensity ranges from the grid through to production, through to export, to delivery, wherever that product is going needs to be considered. So those are some areas of uncertainty in this business case. When you look at development barriers, domestic offtake will develop, but will not be ready when some of these projects come online as announced. So, if you build it, they will come, sort of is the reference. So domestic offtake will come, but it won't be ready right away. The general delivery timeframe we are seeing for electrolysis units worldwide is about 2 years. So proactive contracting strategies and procurement needs to be done to make sure you meet those FID deadlines. Finalizing of the Canadian investment tax credit will be key. I know the new federal budget comes out here this month, so it'll be interesting to see what updates is in that with regards to the Canadian investment tax credit. And like I mentioned earlier, standards are evolving globally for production and offtake requirements. So understanding those changes and staying on top of it is really key. And then areas of opportunity, as mentioned earlier, the ESIA process, the Environmental Social Impact Assessment process, is very, very mature in Canada. So it is an area of opportunity. Projects developed within Western Canada can also access funding like the Clean Fuels Fund, the Strategic Innovation Fund, and the Canada Growth Fund, and many others. It can be stackable as well, so that can really help out on business cases. Connecting with organizations for international trade. For example, like the Trade Commissioner Office is a great way to connect for international markets. It's a great organization. You can look that up on Google, the Trade Commissioner Office. They actually help connect Canadian businesses to global markets. So trade is a great opportunity. And we've all collectively learned so much about how to stand up this industry in the last 5 years. It'll be exciting to see these projects move forward here in Western Canada. So Segar, I'm going to pass it over to you so you can run through your business cases.
Thanks, Beverly. Beverly discussed about the various factors have affected one project. What I'll try to illustrate through my examples here is why it is so important for innovation and thriving amid ambiguity. I always advise our clients as well, when you're going through the phases of scoping and pre-feasibility, feasibility, don't have an FID lens at the scoping stage. You need to make some decisions and not look for precise points of estimate at this stage. So in the first case, this relates to a P2X project from wind power to electrolysis to green ammonia. The challenge relates to the suboptimal production, which is yielding high levelized cost. And this is really driven by the intermittent nature of the wind and the continuous operating requirements of the synthesis plant. And here the recommended solution is you could either store power for continuous hydrogen production or store hydrogen for continuous ammonia production. We completed some optimization work and recommended hydrogen storage as an additional component to their value chain, which improves and could move on to the next stage of project development. The second example here relates to an opportunity loss from integrating offshore onshore wind for hydrogen production. This particular region has locational spot prices for power. And we developed a decision matrix for this client. In some locations, it was more advantageous to sell power directly to the grid. And in some areas, it was okay to use power for hydrogen production. So it was really a decision matrix based on locational constraints or opportunities that the decision was being made. The third one relates to a project yielding high carbon intensity values by sourcing power from the grid for hydrogen production. And these are still draft legislation for investment tax credits. But what we saw was that this project was not qualifying for the top tier of the investment tax credits. The suggestion was here is let's look at a combination of grid and some behind the meter power solutions. And even if the capital costs were a little higher, for example, you could move to a different electrolysis technologies, which could be more efficient in terms of less power consumption, but could have a higher capital cost. But the investment tax credits could far way greater to avail from the top tier investment tax credits. So the last one relates more of an opportunity than it is a challenge. But how do you accelerate hydrogen development in a region? So this client was a owner of very valuable salt cavern storage assets, and instead of waiting for somebody others to develop these valuable assets, we did a market study and look at ways of all the ecosystem here and how one could attract investments in other parts of the value chain, whether it's on the feedstock side, whether it is on the offtake or pipelines or the grid, port facilities, so that it's a hub development more than just looking at salt cavern storage development. So those are the four examples, and I think what it illustrates is that we need to make decisions through some innovation amid all the ambiguity that exists now. So let's bring all this together. Again, after all, we are a consultant, so I need to come up with a list, and I picked for the number for today. You heard from both of us the challenges, the areas of uncertainty, the development barriers, and the opportunities to accelerate the project's development. And if I were to conclude with some four takeaways, not getting into the details and the examples that Beverly and I have spoken in the last few minutes, let's look at the policies first. It's great all the policies announcements that's happening. But these need to flow to the projects quickly. Lots of announcements, lots of investment tax credits, but we're not seeing this flow through the programs flowing faster to the projects. And because it's important for the projects to avail of these programs, and then further we need to start reviewing where the other gaps are so we can de-risk further through policy interventions. And the other one relates to the supply side. There seems to be a significant focus on the supply side when it comes to infrastructure development on the supply side. we need to take a more holistic approach, or we would really risk having a supply side stranded. There is the third one is there's lots of ambiguity, and probably more number of studies may not necessarily help here. We need to make decisions in uncertainty and utilizing new tools and talent that the sector is developing. Finally, let perfection not be enemy of the good. Of course, we cannot compromise on safety, but let's learn from doing and become comfortable with few failures. And we need to define what failure is. And I don't think in any of this project development, it's all learnings more than failures. So let's get comfortable and learn from doing. Thank you. That brings to an end our planned presentation. And I think we'll answer some of your questions. Before we do that, I also wanted to make an announcement. Probably many of you are aware. There is a Canadian Hydrogen Convention at Edmonton starting April 22nd. WSP is one of the sponsors there. Beverly and I will be there, and look forward to meeting many of you there in person to follow up from this webinar. So we'll move on to responding some questions now.
Thank you. Thanks, Sagar and Beverly, for a fantastic presentation. Please continue to log your questions in the question box on the control panel. I will start with the first question. How do Power-to-X project reshape transportation and infrastructure for clean energy?
Maybe I could take that one, Sagar?
Yeah, please.
So just to say that one again, Sharon, I just want to make sure I understood it. It was how do P2X projects reshape infrastructure in clean
Transportation and infrastructure, yes.
Yeah, so we're actually seeing a lot of that already in the transportation sector about P2X projects. Our team has been asked about hydrogen as it relates to airports, refueling stations, hydrogen refueling stations, hydrogen to methanol refueling stations. And, you know, our team's actually completed detailed design for the ATCO CP Rail refueling station here in Alberta. There's a station in Calgary and Edmonton. So we're already actually seeing P2X projects reshaping transportation right here at home in Alberta. If I were to think globally about transportation, I think another place that we would see growth right away is in the ports and marine space of the transportation sector. Many of these P2X projects globally have an export facility as part of the plan. And a lot of these ships, number one, need to be built, ammonia ships, methanol ships, that will help the transportation sector, as well as the port infrastructure to accept those ships. So I see a lot of facilities needing to be upgraded as well as built new in the transportation structure. So yeah, airports, refueling stations, ports, transportation will have a big part to play in the hydrogen P2X space.
Bev, if I can continue with your response, I don't want to forget about the road transportation. If you really look at the one of the characteristics of hydrogen and where it can be used, definitely on the road transportations, we have the electric vehicles, and the characteristic is short duration. And what hydrogen brings is long duration storage. So we will start seeing hydrogen in heavy transportation sector, and Canada has lots of pilots being currently carried out, especially in Alberta and the BC. So I think P2X projects we'll see in the road transportation as well, Beverly.
Thank you.
Hopefully that answered the question.
Thanks. How mature are the process engineer with building hydrogen solutions today? And is it an easy transition from other gas technology?
Do you mind if I jump in here as well, Sagar?
Please do. I'm no process engineer, so.
I am not either. I'm a mechanical engineer, but you know what? Working in the energy industry for 20 years here in Alberta, we've been making hydrogen, blue hydrogen for decades. It's just not been a product that we've sold. It's just been part of the gas processing infrastructure. So I think especially in Alberta, which is what I know, what I'm familiar with, the process engineering skills that we've all had for decades and the teams we've worked on are very transferable to hydrogen and P2X projects. We've seen it already. I mean, our process engineering team here at WSP, they're able to, design these projects, do all the things that they do really well, transferring that knowledge from energy over to P2X. So, the process engineers, they just take what they know and apply it in a new way. I think it's completely transferable.
Thank you. Between the different power to X projects, for example, e-ammoniac, e-methanol, e-SAF, does one of them seem financially more reliable?
That's you, Sagar, finances.
So this is still an ongoing debate about which one is more financially more reliable, and there is no clear winner because it's still an evolving stage. All these technologies. I came across a report where it compares ammonia shipping versus methanol shipping. When you look at the life cycle costs, the capex for ammonia production could be lower than methanol, but the shipping costs for ammonia could be higher. So one caution for the sector is that we need to be careful of comparing options on one metric like the financial. At this stage of development, how the sector is evolving, we need to be open for various P2X options. I wouldn't recommend any option to be eliminated yet. There will be some learning, and we could be finding different P2X projects being suitable for different needs based on locational and the operating characteristics as well. But it is fair to say is that all these technologies are rapidly evolving, and we will quickly map what works best for which type of application.
Thank you. The next question relates to water. Are water rights the biggest political hurdle, in the development of hydrogen projects?
Goodness, do you mind if I jump in on this one,
Yeah.
Sagar? Okay, so are water rights the biggest hurdle? I would say they are a hurdle, but not the biggest. If I take it back to, areas of uncertainty in the project pillars, when you look at power, water, land, ports, regulatory, those are all pieces of, or hurdles, I guess you could say, in the hydrogen development of hydrogen projects. So water for sure is one of the pillars. I wouldn't say it's the biggest. There are always ways to minimize water consumption. We've seen numbers where the water consumption for P2X, say again, a hydrogen to ammonia, I'll give that example, where 80% of the water is actually for cooling, not for making of the hydrogen. So if you switch that cooling to air cooled instead of water cooled, you've really reduced the water required for that project. Other things we've looked at is, in trying to understand if there's industrial waste water nearby that we can take and clean and use as our water supply. So yeah, so while it is a hurdle, it's a hurdle that's you can mitigate. And to bring it back to what Sagar mentioned about the Canadian Hydrogen Conference, two of our engineers are actually doing a presentation in the technical session about water as it relates to hydrogen projects. So if you are going to the hydrogen conference, you can look out for Michael Fabric and Steve Waldner's presentation in the technical portion of that series. Sagar, anything to add there? I don't know.
No, we'll move on. There are a few more questions. Just conscious of the time.
Okay.
That's a good response. But, yeah.
Thank you. We receive really good questions. Thank you for sending all this through. The next question is, how, in your opinion, hydrogen is going to replace petroleum sector? Is
Being an
hydrogen going to,
Alberta, take it,
do you
Bill.
want to do that one, Sagar?
No, you.
Yeah. I don't think it's going to replace the petroleum sector. I think the petroleum petrochemical products will continue to be part of our lives for a while still. Plastics, lubricants, coatings, things we need in life come from the oil and gas sector. So, the goal of using hydrogen as an energy vector is to decarbonize and work with the oil and gas sector. So, yeah, I think it's part and parcel. It comes with it. It's not going to replace it. It's a piece of the puzzle to help with decarbonization.
Yeah, and just to add, let's not forget that hydrogen could become a feedstock for the petroleum sector. So there's the advantages of hydrogen. It is such a multi-characteristic product, right? So you will start seeing hydrogen as a feedstock for many of the petroleum products as well.
Thank you. Next question is related to government incentives. Are government incentives required to see these types of projects come to fruition?
I'll try this. As governments or organizations, I think it's fair to say that we have established a reduction of greenhouse gas emissions as their objective. And also there is good acceptance now that hydrogen and P2X projects play a significant role. And this sector is at the nascent stage. So in this context, governments can play an active role to accelerate the development and de-risking the projects, because that's what we're looking for, is how can we de-risk the projects. We believe in the product, we believe in that this could contribute to reduction in emissions. So the intervention could come from policies, regulations, trade agreements. So it's not necessarily incentives, but the intervention could come through many ways. And like any other energy sectors developments we saw in the first, there are challenges in the initial stages, and that's where we need government support in the initial stages, which provides the investor confidence to develop these projects.
Thank you. I will take the last question. Is H2 from intermittent energy source, for example, wind, solar, or tidal, viable? And what is the generally expected green H2 growth rate?
Let me be quick. I'll take the second part first. I think we need to be careful of any hard forecasts when it comes to green hydrogen growth rate. I provided some statistics in one of my slides in the beginning. It's nice to understand directionally, and it's more important to understand the complexities, interdependencies, and the trends. Let's not just look for a very precise not cost, but production forecast of hydrogen. Let's understand the trends that are positively impacting the growth of this sector. The second one, when it comes to hydrogen from intermittent energy source, I would say definitely. I think it is viable to have hydrogen from intermittent energy source. It requires various optimization of components across the value chain, and some intervention is required through other components, as we discussed through the example. It could be power storage, it could be hydrogen storage, or taking a small portion from the grid. But technologies are getting better, and optimization tools with the data that is available now are getting better and better. So I think it is definitely viable. A caution though is it needs to be very site specific to be evaluate how significant the benefit is taking power from behind the meter solutions like wind and solar.
Fantastic. Thank you so much. Thank you for all your questions. All the questions that we didn't have time to read today will be answered directly by the presenters. So thanks again, Sagar and Beverly, for a great presentation, and thank you all for joining us today. Please feel free to reach out to the presenters via the contact details shown on the screen, and we will wrap up the session now. Thank you, everyone.
Thank you, everyone, for participating.
Thank you. Appreciate your time.